All right, if you're watching this video, it's because you need help with this packet right here. This is the geometry class, chapter 6. It deals with constructions, and there's a lot of different interesting topics that we're going to talk about in this chapter. It's there's congruency, there's transformations. We're going to use a new tool, perimeter, circumference. There's a lot of stuff, and that's very important in this chapter. So we're just gonna go ahead and just jump right into it. Make sure you guys put your name at the top and the period. And also in mathematics, congruency, congruency refers to the property of two geometric figures being identical. And here's the catch: in shape and in size. So when we say two objects, and it doesn't matter what objects they are, but if we say there's two objects, they are congruent, all right, if they are identical in shape and in size. Okay? Now, the simplest shape of them all is the triangle. So we got a bunch of triangles right here. We said that you cannot have a geometric shape that has two sides. It has to have three sides, because if you think about it, you need the third side. If you only have two sides, you cannot complete the shape. So unless they're curved, but if we're talking about straight lines, you have to have three sides. So we're going to start off with triangles to try to explain congruency. These are the three main theorems that prove that two triangles are congruent. So anytime you see the S, that means side. Anytime you see the A, that means angle. Okay? Now let me explain something. So if you have two triangles, say if I have one triangle here, and then I got another triangle, and I'm going to make this one a little bit bigger, you would say these are not congruent, right? Because even though they're the same shape, they're not the same size. Now, we can probably say, hey, this angle is the same as that angle, okay? These two angles are the same. This is a 90-degree angle, and that's a 90-degree angle, so those are the same. And then this angle is the same as that one. So this one is angle, 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 meaning all three angles are the same with these two, but they're not congruent. And this is an example of not a theorem, the opposite of theorem. I guess this is, or I guess it could still be a theorem. But either way, point of the story is these two triangles are not congruent even if all three angles are the same. Now, in this example, we're saying if all three sides are the same, if this side's the same as that side, this is the same as that, and then this one's the same as that one, all three sides, then yes, this is congruent. So there are lots of shortcuts that don't work, and in this case, I'm calling theorems and postulates shortcuts right now. These four are the only ones that work. Okay, and I'm going to talk about two other ones, and I'm going to put them right here in the middle. But anytime you have a side, so here's one side, and we know that's congruent to that side. And then we have an angle in the middle of two other sides. So here's another side, and here's another side. And if we say that this angle in the middle is congruent to that one, they're both congruent, then this is a shortcut, meaning you don't have to measure this side. You don't have to check for this angle. You don't have to check for this angle, okay? It's congruent just by us knowing side, angle, side. So that's a shortcut. So right now we're not proving these. I'm just telling you that these are shortcuts. Let's see of one that doesn't work. Okay, so if I have an angle, let's just say it's this big, and I have, oh man, I kind of wish I would have picked the smaller angle. Let's see, let's scratch it. If I have an angle and I say this angle is congruent to this angle over here, and then I say this side is congruent to this side, I can make this triangle go like this, and I can make another side go like that, and we can say these two sides are the same, but notice they're not the same triangle. Now this one spells I guess you can think of it as a bad word, but it's not really that bad. Angle, side, side. Angle, side, side. Spells ass. That does not work, okay? Now the opposite also doesn't work. Side, side, angle. That doesn't work. So these three are the ones that don't work. These four are the ones that do. So if you ever have an angle, a side and an angle, so an angle in between, so here's this angle, in between, a side in between two angles. Notice how it goes angle, side, angle, angle, side, angle, angle, side, angle. So anytime you have a side in between two angles, that's a theorem. That works. This one is the same as that one, just backwards. It does not work, okay? Now what about angle, angle, side? So if you have one angle and then another angle and then a side, angle, angle, side, then this one works, okay? So I hope I did a good job explaining the theorems. These four are the only ones that work, okay? So let's take a look at the first example. We have, and it doesn't matter where you start. You just kind of have to figure out, okay, what comes first. We know that if two triangles share a side, then this is congruent, okay? So this is a side, side, angle. I think we're gonna start with angle because angle is the closest. It kind of, I can kind of see like angle, side, side. So that's what I see. Angle, side, side. Oh, and right away, we already know this is not a theorem, a congruency theorem. So that's wrong, okay? And if we would have gone the other way, we would have said side, side, angle. Same, doesn't work, okay? Even though these two triangles look congruent, we can't for sure say that they are congruent. That's the only thing. We just can't say for sure. I'm not saying that they're not congruent. I'm just saying that we can't prove it, okay? Now what about example number 2? Angle, side, angle. So angle, side, angle. Angle, side, angle. So this one works, okay? See if you guys can pause the video and see if you guys can figure all of these out on your own. There's 10 different examples. Each example gives you guys 1 point, okay? Example 3, all 3 of these have the same 3 sides. So this is side, 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 and that works out. Number 4, anytime you have 2 lines that cross and intersect, the alternate angles are the same. Okay, so we learned that in class. So this is angle, side, angle. Let's see, angle, side, angle. I just got to make sure that they correspond over here. So angle, angle, side, angle. Okay, so that checks off. So that's angle, side, angle. Over here, number 5, we know that we have a similar side, one side and one angle. That's not enough information. You need at least 3. So if you notice, all of these at least have 3. This only has 2. So it's not good enough. Number 6, let's see. We know this angle is the same as that angle. Again, anytime you have an X, then the angles in between are congruent. So we have angle, side, angle. And that for sure is a congruency theorem. Over here, looks like we got the same thing. Side, angle side. So it's almost the same thing, it's just flip-flop. So that's congruency theorem. Number 8 is similar to number 3. They share an angle in the middle. So this is side, side, side. That checks off. Number 9, they make an X. So these are the same. So this is side, side. So side, side, angle, angle, side, side. So side, angle, side, checks off. And then 10 is side, side, side. You can tell that all 3 sides are the same. So good. So there's only, I think, 2 examples where they're not congruent. Let's go ahead and flip the page. We're now going to start talking about transformations. Now there's 4 transformations that we're going to talk about. The first one is rotation. Anytime you have an object and you rotate it, it stays the same shape and size. So this is congruent. Okay. Reflection isn't exactly, well, it's the same shape, it's the same size, but actually it's not the same shape. It's kind of like, imagine if I took a photo of my picture right here, of like my face, okay? And then both sides are not the same, okay? At least on my face. They probably are on yours, but unfortunately on mine, they're not exactly the same. And so if I was to copy this side and put it on this side as a reflection, and then I did this side and that side, it'd be 2 different bodies. So what I'm trying to say is that they're the same size, but not the same shape. It's just a little different. So a reflection is not congruent. So let's put the symbol for congruent and then give it a slash to say it's not congruent. A translation is a push. So if I push this eraser, or I push it sideways, or it doesn't matter which way I push it, it's going to stay the same. So this is congruent. And the last one, dilation. Notice in this case, the shape got smaller. It shrunk. Obviously, that makes it not the same shape anymore, or same size. Excuse me, the same size. So this is not congruent. Now, I did tell all my students that number 1, we were just going to skip it because there's a couple things that we didn't necessarily cover. You would have to basically write down the points, the coordinates for each point. So L would be 0, -3. Z would be 1, 2, 3, 4, -4, 0. And then this would be -5, -2. Okay? So when we rotate, and in this case it's counterclockwise, so clockwise, a clock goes like this. Counterclockwise, it means it goes to the right. Okay. We're going to have to basically switch these values up. We're going to have to flip them, and flip them. Yeah, so we're going to have to switch the numbers. And then when we do counterclockwise, essentially the y value, it turns into a negative. If we were going clockwise, it would be the x, but since it's the counterclockwise, it's the y, so we're going to make the y negative, and then we're going to switch them. And this is one of the reasons why I told my students to skip it. I'm like, hey, this is good, but maybe if we were focusing a little bit more on transformations, but this is just a quick little lesson on transformations. But so we flip them, So, and then this one becomes negative, but in this case, the negative becomes positive. So it's really going to be 3, 0. So 1, 2, 3, 0. That's going to be our L. And then this one, the negative becomes positive. So 1, 2, and then the 5 stays the same, so it's -5. So we're going to go down 1, 2, 3, 4, 5. So that's J. And then Z is, the 0 turns negative, but you can't make a 0 negative, so it's going to stay the same. So it'll be 0, -4. So 0, -4. And there's this triangle rotated 90 degrees counterclockwise. Okay, so it actually looked more like that. So I did say we're going to skip rotations. They're fun, but maybe that's for another lesson. A translation is just 4 units. It's just moving left or right or up and down. In this case, it's 4 units to the right, 1 unit down. So I'm just going to do 4, 1, 2, 3, 4, then 1 down, 1, 2, 3, 4, and then 1 down, 1, 2, 3, 4. Oh, snaps, and then 1 down. So that's what it's supposed to be. There's a triangle, translated 4 units to the right and 1 down. So go ahead and try to do this one on your own. Pause it. I'm going to go ahead and explain number 4. And then the instructions over here are missing, but it's basically supposed to say describe the transformation. Okay. So number 3, translation. 1 unit up and 1 unit to the right. So 1 up, 1 right, 1 up, 1 right, 1 up, 1 right, 1 up, 1 right. Then we're just going to connect these. So still congruent, still congruent. A reflection, remember, it's no longer congruent. And in this case, they want us to reflect across the x-axis, which is right here. And so what you do is you count how many steps to the mirror, that's basically the mirror, and then you do the opposite going the other direction. So see, 1 going that way, 1 going opposite. 1 step to the mirror, 1 step away from the mirror. 2 steps to the mirror, 2 steps away. 1, 2, 3, 4, 1, 2, 3, 4. So then we just connect all the points. And even though it's not exactly perfect, that's what it would look like looking into a mirror. Describing the transformations. This one seems easy enough. It's just 1 unit to the right. This one looks like it's a reflection right there. Reflection at x equals 3. 1, 2, 3. So where x is equal to 3. This is a reflection also. And we can tell this is at the x-axis. This one's interesting. You would think that it's a reflection right across, but G is right here, and here's the other G. So if I was to go into the mirror, I'd take 2 more steps, but it's actually over there. So what's happening right here is this is a rotation. And since they're exactly across, this is a 180-degree rotation. And 180 degree doesn't matter if you go left or right, it's going to end up in the same spot. So anyways, I just briefly wanted to talk about the different types of transformations because some transformations make things congruent and some don't. And that's why this chapter, even though, this section of this chapter is called Congruency and Transformation, it's really just congruency. It's important for you to pay attention to the things in your life that are the same shape, same size, and also maybe taking it up another step and just kind of thinking, what are the definite, like, for example, this is one of the conversations we had in class. So if you know what a good friend is, try to define what a good friend is, and then try to find more good friends. Because growing up, I grew up thinking that some of my friends, or the people that I hung around with, I grew up thinking that they were my friends, but it turns out that they were not my friends. And there was little clues that I just didn't necessarily, make the connection with at the time. I can tell you guys, I had a friend that, we all skated together. We all grew up in the same neighborhood, the same block, and we would hang out. And so I thought, since we were all part of the same little group, I thought we were all like, good friends. But one of the things that I always noticed is that, like, when I got hurt, he would laugh, and he would laugh hard. And it was always kind of like noticing, like, I noticed that he would laugh hard when it was me, not necessarily other people. So like little things like that kind of tell you, like, hey, you know what? This is not the same as over here in this group. So pay attention to the differences as well as the similarities, like who has those good qualities of good friends and good people, or a good job, or good health habits, whatever you want to call it. But just pay attention to the things that are the same and versus not the same. So we're going to move on to the next section. I call this a new tool, but just so you know, you've seen this tool before. This is a compass. That's what we're going to use. But what we're going to do is we're going to construct. So a construction is the process of creating geometric figures or solving geometric problems using a set of precise and well-defined steps, often using only a straight edge. Here's my straight edge. Or and a compass, not or. I think you got to use both. So anyways, so let's do one of the easy constructions. Let's do an equilateral triangle. Okay. So I'm going to go ahead and just draw a line. Okay. I'm going to label the endpoints. And I want to make a triangle that's equilateral using this segment. So what you do is you open up your compass to the same size, and then you pick one of the sides. I already taught you guys how to hold it. Just hold the top, and I'm just going to go ahead and draw an arc. And then I'm going to switch the compass from A to B. So put the needle right there. Draw the arc. And they make an intersection points. I'm going to label this C. And this is pretty cool. This is an equilateral triangle. Okay, so this side is congruent to this side, and it's congruent to that side. So that means this is 60 degrees. That means that's 60. That means that's 60. Okay. Now let's do a right triangle. A little bit more complicated. We will draw a line. And okay. Actually, I'm supposed to draw like the whole entire line, but what we're gonna do is we're just gonna go ahead and pick 2 points. Okay. And I want to open up my compass bigger than halfways. So I'm going to just make sure it's a little bit bigger than half. Hopefully you guys can see that. Let's scoot this up just a little bit more. Okay. So this compass is wider than half, I'm going to draw an arc on the top. I'm going to draw an arc on the bottom. Actually, I guess I'm just drawing one big arc. I'm going to do the same thing on the opposite side. And what you're going to notice is that there's going to be 2 points. If you connect those 2 points, and I'm actually not going to connect both points. I'm just going to connect the top because the whole point of this was to make a right triangle. So then I will label this a point. I will connect these 2 points. And this is a right triangle because that's 90 degrees. So basically what I taught you guys how to do right now is how to draw a 90-degree angle. And then we just basically made that into a triangle. Okay, so easy, a little bit more work, but it's pretty cool just to learn how to do these constructions. Let's go to the back. All right, let's construct a square next. I'm gonna draw a line, and I think it's gonna be similar to what we just did, with just one extra step. This time I'm just gonna go ahead and draw the, I was being a little stubborn. I'm just gonna go ahead and draw the line all the way through, and I'm gonna label these 2 points. Let's label them X, Y. I'm gonna again make this a little bit longer than halfways. I'm gonna draw an arc. The bottom. And the top. I'll do the same thing over here. Just for the record, this is not like super nice, but anyways, I'm next gonna draw a point, and I'm gonna go ahead and draw a line. Now typically I would use a pencil, but I have a pen right now, so we're just gonna use a pen. So we want to take the length of this square, okay? So what I'm saying, I'm gonna use this side as my square, and so this is gonna be part of my square. So I'm gonna make sure it's the same length, and then what I'm gonna do is I'm gonna put it right there at that point, and this right here is gonna be one of the corners for one of my squares, for one of the sides of one of my squares, my square. And I'm gonna go over here, I'm gonna draw another arc, and then I'm gonna go back to this dot and draw another arc. And where they intersect, this just makes it perfect for us to make the square. So all of these should be 90 degrees. Doesn't look exactly perfect. And all the sides are the same. And they're also parallel. They also just happen to be parallel. So there's our square. Now we're gonna end this section with one of my favorites. So a hexagon inscribed into a circle. Now you might think that's difficult, like how are we gonna do a 6-sided shape inside the circle? But it's super easy, so that's why I like doing this one. So what you do is you open up your compass so that it shows the radius. I think I just need to look a little bit more, or a little bit less now. So you gotta make sure it's exactly the radius. Okay, I think there I got it. So I'm going to double check. Okay, good. Yeah, it looks like I got it right on the circle. So you're going to pick any spot on the circle. You're going to draw an arc. And you're going to keep going to where it intersects. And you're going to keep drawing arcs. All the way around. All right, got it. And I think I might have made this one a little short. But that's okay. So I don't know if you saw that, but it's not exactly perfect. But let's go ahead and draw the dots, our points. And we're gonna go ahead and connect them. And yeah, even it's not exactly perfect, mine, but it's okay. It should still be relatively close to perfection. So even though it's not perfect, let's show that it is. I'm going to say this is congruent to that, that's congruent to this, that's congruent to that. I'm going to say all of these are congruent. Okay, so here's our hexagon inscribed in a circle. Let's flip the page. We're now at perimeter. And that just happens to be our vocab word. So let's write perimeter. So the perimeter describes the distance around an object, so like on the outside. And so I love finding perimeter because this is how you calculate how much fencing you need for like a house, wallpaper, lots of stuff having to do with homes, and I love homes. So anyways, let's just say we had this trapezoid. This is trapezoid. Notice that this is parallel to that. We want to go ahead and do two things. We want to take the actual measurements to find the perimeter, and then we also want to find the perimeter according to their labels. So I labeled this at 70, 120, 65. It doesn't mean anything. I just made up some numbers. So it's just practice. But what you're going to do is you're going to say, since this side is congruent to that side, we just want to add up all these numbers. So it's 70 plus 65 plus 65 plus 120. If you add these numbers up, this is 65 and 65 is 130 plus 70 is 200. 200 plus 120 is 320. But it doesn't tell us what it is. So what I told you guys in class is, how about you guys get your not calculator, your ruler, and you measure each of these sides. This is 9 centimeters, so it's not 120, it's 9 centimeters. This is not 65. This is more like 4.5. 4.5 centimeters. So that means this is 4.5 centimeters. And that's not 70. That's more like 5. So this is 9. 9 plus 9 is 18. 18 plus 5 is 23. So it's really 23 centimeters. Go ahead and circle that. I want you to do that for all of these. I want you to add up what they are. Like in this case, I said this is a square and it's saying this side is the same as that. So that's 40, 40, 40. If I add up all 140s, that's 160. But remember, it's not 160. What is it really? I want you to find out in centimeters. So you need a ruler that shows centimeters. You're going to go ahead and do the same for the rest. I don't plan on doing this. I can give you at least the simple answers, but you need to find the real one. So if that's 70,000, that's 70,000. That's 100,000. This is the same as that side, so that's 100,000. If I add these, that's 200. That's 140. So 200 plus 140 is 340,000. Remember, it's not that. You got to find out what it really is. If you are having trouble adding stuff, just get a calculator. Calculators are a good tool. So 12 plus 18, that's 30. Plus 24, that's 54. Plus 17, 54 plus 17, 54. That's going to give us 71. Nice. Okay, so this is 71. But it's not really 71. Right? We gotta get our rulers. This is 7.5 centimeters. This is 5 centimeters. Okay. I don't really want to do this for you, even though it's so tempting. This one's not, this is 4.5. Honestly, I'm just doing this because I enjoy doing this, and you guys might think I'm weird, but this is actually kind of fun for me. So 3.5. Go ahead and add all of these up, and you'll get the true total of the perimeter. Remember, the reason we're adding everything is because the perimeter is very simple to find. It's the outer part. It's the distance around an outer boundary of an object. And so to find the total, we just have to add it up. I'm going to let you guys figure these out on your own. That way you guys aren't just completely copying everything that I do. And turn the page over. Now, this is fun. This assignment is supposed to be fun. I love this one. It says, draw the outline of your home. You can also make up a home. You can find a home from Google. Just search house plans on Google. If you don't want to do your home, So Google house plans, and you're going to see all kinds of plans. Now, recently, my parents asked me if I could create a house plan for their home that they're going to have in Mexico. So my dad sent me all the dimensions in meters. And so I drew the whole property line. My dad has a couple properties in Mexico, and my mom wants a house in one of the properties out in like the middle of nowhere, so away from the city. And so here's the property lines, and it's actually it's a pretty good sized property. This is a good sized house, by the way. So it's almost like twice my size of my house. It's a good size. So anyways, if you want to see closely, look, it's pretty cool. Here's a street. My dad's gonna have to build a sidewalk. There's a garage. The garage has 2 little storage units. One for my mom, one for my dad. That way they can store all their stuff. These are the front doors. It's a living room. And then there's a big opening to the kitchen table. And then here's the kitchen itself. Then there's a door to go outside or inside. And then over here, there's a bathroom for everybody to use, including the 2 guest rooms. Because I guess one's for my brother, one's for me. And then there's an entrance to the garage from the living room, or to go to my parents' room, which has a bathroom and then a closet. And then, so it's a walk-in closet. So all of these rooms are actually pretty big, because each square is actually it's meter. So this is in meters and not in feet. So like even this living room, this is a good size living room. This is a good size kitchen. Everything's big, big. So in the garage, these are like supposed to be like big SUVs. So I was trying to draw everything like big so that my parents can get an idea of like what their house would look like. But I want you guys to draw something similar to this onto here. And so if I was to redraw this, it might take me a little bit of work. Actually, it might be easiest if I was to just no, it's not gonna go through. I can't really see it, so I can't trace. So I'm just gonna do it on here. So what do I need to do? I need to find the perimeter of the house and the house property. Okay, so in my case, I'm gonna count all these squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and it was 15 and a half. So this is 15 and a half meters from my parents. And then I'm just gonna save you guys the trouble. I already actually know the number. This is 47 meters. So to find the perimeter of the entire boundary, let's get my calculator. Let's clear it out. 47 plus 47 plus 15 and a half plus 15 and a half equals the entire perimeter. Perimeter is 125 meters for the whole thing. But what about just the house? I'm going to go ahead and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is 13 meters. And then this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 meters going that way. Now, I can just add 19 plus 19 plus 13 plus 13. And you might say, Mr. Martinez, you didn't measure this, but since it's a rectangle, I know this is the same size as that, and this is the same size as that. So that's going to be 19 plus 19 plus 13 plus 13. So the perimeter of this house is 64 meters. Okay? And that's what I want to, I basically want to see this on your paper right here. Except in your example, each square is 1 square foot. If you want to change that to meters and you want to make your house bigger, that's cool. You can do that. Okay? Now we're going to go on to the last part of the lesson. Okay. So, perimeter is the outside part. But if we have a circle, okay, that's a sphere, but if we have a circle, it's got a fancy name, all right? The perimeter of a circle is called the circumference, okay? And there's a formula too. We're gonna find the formula in just a little bit. First, we wanna measure this diameter. So let's measure the diameter and then we're gonna measure the circumference. So circumference is all around. The circumference of a circle is the distance around the boundary, okay? Or you can call it the perimeter. So let's measure the diameter. The diameter is almost 12 centimeters. If I wanted to be perfect, I'm gonna say that this is 11.9. Okay, 11.9 centimeters. Now, how am I going to measure the circumference? It's interesting, right? How am I going to measure the circumference? Well, all of you guys are getting some string. And so what I want you to do is I want you to do your best to hold it around the circumference. Okay, do your best. I know it's not super easy. I did have you guys work in partners for this, so you should have an easier time than me. All right. Let's see. Ooh, that's almost perfectly curved. Now, obviously, if you're at home, you're going to need your own string, but I'm going to hold it right here. I think the circumference is this long, right here. So now what I need to do is I need to get my ruler, and I'm going to measure and see how much this is. Okay, so let's see. Line it up. I'm going to put it over here so you can see where I'm at. And it looks like it's a little bit more than 38. 1, 2, 3. So I'm going to say it's 38.3 centimeters. Okay. Now, honestly, I just hope that this works perfectly because I'm using a different circle this time. What we're going to do is we're going to divide the diameter with, the circumference with the diameter, and we're going to get a number, okay? So let's see. We're going to divide 38.3 divided by 11.9. 38.3 divided by 11.9 equals, pretty close. It's about 3.21. Okay, not exactly the number I was looking for, but I was looking for a special number. Have you guys ever heard of pi? Pi is an approximation of 3.14. Okay, so I must have not measured exactly right. But when we did it in class, some people were lower than this number, some people were higher than this number. In my case, I was a little bit higher. I overshot it. Okay. 3.5 is an interesting number because it's the relationship between the diameter and the circumference. Okay? Circumference, diameter. Okay? So if you measure the diameter, you can multiply it times pi, and you essentially get everything around. Okay, so that's our formula over here. Our formula for circumference is diameter times pi. Now, some people, you might say, Mr. Martinez, I've never seen this formula. And it's probably true. You've probably never seen it. Because most teachers tell you it's 2r times pi, or 2 pi r. Why do they say this? Because it's easy to remember. Circumference is 2 pi r. But the truth is, it's the diameter times pi. And that's the relationship between all circles. All circles, you can measure the diameter, multiply it times 3.14, and then you get the circumference. Or if you know the circumference, you can divide by pi, and it'll actually get you the diameter. So when we flip the page and we want to find the circumference of these circles, we're going to basically use the formula diameter times pi. So that's the formula for circumference. Or circumference equals 2r times pi. Okay? Now, why is it 2r? Because the radius, this is the radius, is half of the diameter. The diameter is 20, so I know that the radius is 10. So if I want the diameter, I just multiply times 2. So 2 times 10 is 20. Okay? Now let's answer this question over here. So this is pi, often represented by the Greek letter. That Greek letter. It's a mathematical constant that represents the ratio of the circumference of a circle to its diameter. So these are super easy to calculate. You literally just get a calculator. If I know that the diameter is 10, I just do 10 times 3.14. So then it's my circumference equals 31.4 centimeters. Over here we got 5 kilometers, so 5 times 3.14. That gives us 15.7 kilometers. Okay? What about if they give you just the radius? If they give you the radius, you got to double this. So it's not 12, it's 24. So then you do 24 times 3.14, 75.36 meters. Okay. So again, if you are given the radius, like in this example, it's 2. You need the diameter, which is 4. Okay? You multiply 4 times pi. This one, 11 times pi. This one, 20 times pi. 14 times pi, 8 times pi, and in this one you got to double it. So it's 14 times pi, and that's going to be the same as this one over here. Except this, and they're both in inches. So these are the same 2 circles. Okay, there you have it. I think we're done with this. I'm not going to give you guys all the answers. Make sure you guys also do your warm-ups. If you guys have any questions or you need any of the tools, whether it's a ruler, some string, calculator, or where's the compass? I just had a compass. Compass, let me know. I have a bunch in the classroom. So really, really interesting chapter. We covered a lot of different stuff. It's a long video, but I hope you guys enjoyed it. I'll see you guys tomorrow or next week or whenever. All right. See you guys later.